In this video, we're going to look at a demo to help us understand the pressure in a liquid. Now, to start here, I have an aluminum cylinder. I have an aluminum cylinder in here, which is being supported entirely by the force scale. Now, the force scale shows a reading of 10 newtons. And what that means is that gravity is pulling down on the aluminum cylinder with a 10 Newton force. And that 10 Newton pull of gravity is being balanced entirely by a 10 Newton upward pull by the force scale. Now what I'm going to do is add some water into this container that has the aluminum cylinder in it. I have a little bit of food coloring in here to help you see the water a little easier. Right. Now we can see that the reading on the force scale has reduced to about 9 newtons. Does that 9 Newton reading actually mean that gravity is pulling down with a 9 Newton force instead of a 10 Newton force? Well, of course not. Gravity is still pulling down with a 10 Newton force, but now the water is pushing up on the bottom of the aluminum cylinder with a 1 Newton force, so that the force scale only has to provide a 9 Newton upward force. Now I'm going to put some more water into the container. Okay. Now the reading on the force scale is 8 newtons, which tells us that the water is pushing up on the bottom of the cylinder with a 2 Newton force, so that the force scale only has to provide an 8 Newton upward force. Okay. And now I'm going to put some more water into the container. Now the reading on the force scale is 7 newtons, which tells us that the water is pushing up on the bottom of the cylinder with a 3 Newton force. Let's recap the demo now, except without the water there. I'll just act it out. All right, so when the bottom of the cylinder was about that far beneath the liquid surface, the water pressure pushing up on the bottom surface of the cylinder was strong enough to exert about a 1 Newton upward force on the bottom of the cylinder. When the bottom of the cylinder was about that far below the liquid surface, the water pressure pushing up on the bottom was strong enough to exert about a 2 Newton upward force on the bottom surface. And when the bottom of the cylinder was about that far beneath the liquid surface, then the water pressure pushing up on the bottom was strong enough to exert about a 3 Newton upward force on the bottom surface of the cylinder. What does that tell us? Well, what it tells us is that the strength of the pressure increases with depth. So the further you are below the surface of the liquid, the greater the pressure in the liquid. So in the next video, we're going to derive an equation which tells us how the pressure in a liquid changes with the depth beneath the surface.